This way, if you have questions, you always can go back and be like, wait, how did we solve that in class? All right, so practice test. As I just stated, you can use your calculator. What this means is you have to show supporting work, right? To receive full credit, show all supporting work for answers for every part of each question. So I should see work everywhere. There is, because I go through and I'm like, oh, okay, so number 1 is worth 2 points, right? I have to see how you solve for the x of the vertex. Then I have to see you plug that back in and find the y. Right? I have to see your work. Okay, so I'll be giving you the vertex equation. So for instance, on your test, I'll say find the vertex x equals negative b over 2a. Just like your quiz, I gave that to you. Yeah, remember that? No? Okay, so I gave it to you. So that way it'd be a little more helpful. Let's go through and I'm going to point out and see what a is. A is 2, B is negative 4, and C is negative 6. Okay. So keep in mind, I'm going to be giving you like vertex form. I'll give you the vertex equation, negative b over 2a. I give you quadratic formula, right? Negative b plus minus square root b squared minus 4ac all over 2a, blah, blah, blah. Like I give it to you. I'm not going to say, that's quadratic formula, but like you have to know how to use it. So ideally you've done the homework and like you've worked through enough problems where you like recognize it. All right, yes. No, I should probably have done that, but I gave them out. I can print some. Yeah, let me just print a couple. How many people need it? Who wants a copy? Yeah.
Is it online?
It's online.
It's online.
Right now, while we're going through it, because I want you guys to like go through it with us, practice. Anyone else? Going once? No? No? One person? Okay, cool. I'll print 3 copies. Okay. All right, so I want you guys to try out number 1 and number 2. Try out number 1, number 2, see if you can do it yourself. Did you guys already try it out? Okay, try out number 1 and 2. We'll go through it in 1 minute. Try out number 1 and 2. See if you can identify how to find this.
So we just find. Actually,
One or no?
axis of symmetry is x.
Yeah, but isn't the x that is the axis of symmetry not the same as like the x?
It's the same thing.
Oh, so one answer is I think you have to find x first. Yeah, and then we put it in that table. After x is 1, so y equals 1 x. I think.
That's okay. Thank you.
Yeah. Yeah, I don't know the punch it into it.
Wait, so we just do that x equals
Over 2a. And then you find the x. But you need the x and y coordinate. You have to have the x and y coordinates.
I don't know how to do this.
Okay, sweet. So it's good we're going over it. All right.
So
I for sure forgot.
Okay. Be kind. That's not kind words.
Yeah.
Shh. Just kindly ask him to, not talk. That'd be the nice thing. Okay, so here we go. And we're gonna hit number 1, 2 really hard. So find the vertex. X is negative b over 2a. So we have to find the x and y coordinates. To find the x, negative, our b was negative 4. Over 2 times a was 2. So this is 4 over 4, so it is 1. My x coordinate is 1. But we're trying to find the vertex. Right now I have x equals 1. What's the y value? We don't know, so we have to plug this back in. Gotta plug it in. So my y is going to be f of 1. I'm plugging x equals 1 into the equation. 2x squared minus 4x minus 6. Okay, so 2.
She crossed it out as she was giving us.
So, Correct. So I am going to let you use calculator the whole time. I think you're getting water at the time when I was discussing it. This is like this is why I have the whole like bathroom pass thing, and like people need to be in class because what I say I don't like repeating. Okay, so what this means is you have to show your work for each and every part of the question. If you have the right answer, but there's no work to show how you got it, you get 0 points. Makes it pretty easy for me to grade. Don't make it easy for me to grade. Put your work so I can grade it. Okay. Huh? So if you plug in your x value you found. So we found x equals 1, right? So now everywhere where you see an x, you plug it in, and then you'll find your y value. So this is going to be 2 minus 4 minus 6. So that's going to be negative 2 minus 6, which is negative 8. Perfect. So
Did you do the 1 squared first and then times 2?
yeah, you have to do the 1 squared. 1 squared is 1 and then times 2. Order of operations, exponents before multiply, right? Please excuse my dear Aunt Sally. You got to do exponents before multiplication. So it says on your actual test, I'm going to try to make it as easy as possible so you don't mess up. I'm going to put the parentheses and I will put a little comma. That way you know, hinty hint, you have to write an x comma y coordinate. You can't just write x equals 1 because that's a line. X equals 1, y equals negative 8. Okay, but ideally the vertex is an x comma y coordinate. So I would write 1 comma negative 8. Wonderful. Axis of symmetry.
1 comma 0.
X equals 1. How did you find that?
We did it.
We did it. So you could say above x equals negative b over 2a equals 1.
Did you just write a
You should say x equals 1.
You write 1
Because
comma 0?
no, because that's a point. Axis of symmetry is literally an axis. It's a line. Because if we draw x equals 1, it's a vertical line. Because it's a constant, right? X equals 1, x equals 1, x equals 1. All the way up, it's a vertical line. Okay, find the y-intercept. So, pause. Ready? Don't say anything out loud. Think. What is the x value for a y-intercept? Turn to the person next to you. What is the x value for a y-intercept?
0.
Aha! 0. Tricky trick. Okay. So exactly. So like just sit down. Okay. So find the y-intercept. The y-intercept is where you cross the y-axis. So to find y-intercept, you plug in x equals 0. So if I plug in x equals 0, I get 2 times 0 squared minus 4 times 0 minus 6. So that's just negative 6. So I just write y equals negative 6?
No.
No, because it's an intercept. Y-intercept. It has to be a point. I'm not looking for a line. I'm looking for a point. So once again, I'm going to try to remember to do this. I'll try to put this on your test so that way there's parentheses and comma to like hinty hint. You have to write a coordinate. So exactly, as Isabella was saying, 0 comma negative 6. Hey, okay. So,
Wait, so you just plug in 0 that?
yep, and we'll find the y-intercept. AKA, it's always your C.
Why did you do 6x equals 0?
No, this is an arrow.
Oh.
This is an arrow you're plugging in. So y-intercept, plug in x equals 0. That was like, yeah, notes. Okay, so the reason I decided to let you use your calculator for this section and not make it like 2 parts, I wanted to make sure you like did the math right. You know, I don't want you to lose points if you don't like compute properly. Whatever, that's fine.
Is the axis of symmetry like the vertex on the table?
So the axis of symmetry is the x value of your vertex. The axis of symmetry goes through your vertex.
So like for a table, it would be
So the next part. Graph the function, you may use table of values. Okay, so look, I give you 5 spaces. We know our vertex, and our vertex always goes in the middle slot. Our vertex was 1 comma negative 8, so I'm going to put it here.
And we also know negative 6 and 0
Okay, hold on.
gets slapped on.
What? The vertex? Yeah. The test is Wednesday. So, no. No, we don't even have class tomorrow. Come on, pop up.
One's at lunch, right?
Yes, it's 12:25. So this is the plan. This is the plan for D period. We're reviewing today, right? This one right here we're reviewing. When we come back on Tuesday, we're going to review, and then Wednesday, the 4th, is your test. Cool. So that way, we'll have a day to like come back, remember about what we're doing. Okay, so we picked the vertex. We're going to pick the x values right around it. So I want 0, -1, 2, and 3, right? So I'm just picking the numbers right around my vertex. Okay, but wait, didn't we already find what y is when x is 0?
Yeah.
Ah, it's -6. How do you know?
Because it told us.
Okay, hold on. One more. One person. Elizabeth, how do you know?
We just did it v is the y-intercept.
It's the y-intercept. So that's what you could literally write. Y-intercept. Look at all this work I'm showing.
Also, the other one is, right?
So that means this is -6 as well, because I draw my little arrows because it's showing, well, why am I drawing these arrows? How do you know it's also -6, Dylan?
Because it's like the same.
Yeah, they're the symmetry. They're symmetry. So whatever the y's are going up on the left side, the y's will go up on the right side. It's literally symmetric. That's why we have an axis of symmetry. Whatever's on the left side is going to be a copy of what's on the right. Okay, so this makes it like not too bad. Because where like you're supposed to be showing work in the middle, like you just write vertex, that tells me you understand what the heck you're doing. You don't have to show more work because you already showed it up above. You write y-intercept, that showed me you know what you're doing. Like you know that's the y-intercept and you showed work for y-intercept. So then really we only have to solve, plug in -1, and then we'll have everything we need. What's my equation again? Let's see. Okay, got it. So I have to plug -1 in. So I have 2 times -1 squared minus 4 times -1 minus 6. Okay. So -1 times -1 is 1. So that's just going to be 2 plus 4 minus 6. So that's 6 minus 6. So that's 0. Which means that this bottom number is also 0. Symmetry. Symmetry. So when I say show all work, it doesn't mean like there has to be lots of pencil on there. I just have to follow your train of thought. I have to understand your process. Like, how did you figure it out? That's all I'm asking. How did you figure it out? If that means showing the math and like computing, or if that means literally writing a word to show me, you see, oh, okay, well, the bottom two I didn't show like mathy work on, but I understand they're the same y values of what's above. You know, all I'm asking is a little like slice of your brain. I just want to know what you're doing. I like to give you as much points as possible, but I got to make sure you understand what I'm testing. Okay, so now I have these. So I'm going to go ahead and I'm going to plot them. -1, 0, 0, -6, 2, let's say, sorry, 0, 1, -8, 2, -6, 3, 0. And we said our axis of symmetry was x equals 1. So x equals 1, I can show my axis of symmetry. What that means is whatever's on the left side is going to be a nice little copy of what's on the right side.
Wait, do we need to do that?
We already did it up there on the number 2.
Right. So, but it says remember to show the axis symmetry. So if you draw it on, I mean that's a hint. Whatever's on your left should look what your right is. And what that means is, it is a parabola. I haven't drawn the parabola yet. I drew the AOS, the axis of symmetry. I'm going to connect my dots to draw the parabola. So look, whatever's on the right side of my axis of symmetry is symmetric to what's on my left. Yeah. So, like this part of the question, like number 3, is probably worth like 5, 6 points. Because drawing the axis of symmetry and then all of your points. It's like 6 points. That's pretty dope. Pretty good. Okay. Do we have questions on this first page so far?
No.
But you'll give us the negative b over 2a?
Yeah. I'm going to give this to you because I gave it to you on the quiz, so I'll give that to you. And when it questions about the vertex, like I'm going to give you vertex form, I'll give you a quadratic equation. This also means I'll give it to you on the final.
You gotta show it on.
I'm literally just going to have I'm just going to have a page where there's like all of the equations we learned. So although like you will be taking the final in this room, like that way you don't have to keep like turning and looking for linear equations. I'll give you standard quadratic equation. I'm not going to write standard quadratic equation and then what it is. Like I'm just going to give you the formula and you have to like recognize to know which it is. It's better than memorizing it though. Okay, we're done with that page. Consider the function 4x squared minus 8x. State whether the graph has a minimum or maximum value. Okay, so don't say it out loud. Don't say it out loud. Don't say it out loud. Think to yourself, how could you tell if it has a min or max? What do we have to look at? Okay, and then decide, like little hints. Hold on, don't say it out loud. Like think, which way is this parabola facing? All right, so is it either going to be a valley or is it a mountain? All right, which way is it facing? And then think if it's going to be a valley. Okay, turn to the person next to you. See what you think. Min or max?
Movies. Because you're the last one.
Wait, no, there was something that was like a
And there's no negative minimum.
It's like it was like from x is like negative or
Then it's a movie.
but it's like immediately
And then if it has a negative, it's a maximum. Oh, it's a smiley face. No, it's a smiley face.
Okay, remember what we went over? So the a is one of your x squared.
Face happy.
So depending if it's positive, if you're positive, you're happy, you're smiling. So literally, it's going to look like a valley, which means you go down to a minimum and then you come back up. If you have a negative a, so for example, if this was negative 4x squared, if you're negative, you're frowning, you're angry, you're sad, right? If you're down, you're negative. So then you would have a mountain, right? They would be facing down and you would have a max. So here we have 4 is positive, right? Since 4 is positive, it would be a minimum. So what you could say, so the work you would show is like a, so you could say a equals 4 positive. You'd even draw like the smile, which means it's gonna have a minimum. So this one doesn't have like, it doesn't have to be like tons of work. Do you see right here?
So we just have to draw smiley faces?
So if you drew this part right here, that's enough work. That tells me you understand to like instantly find min or max. You just look at the A and you understand a positive A means it's facing up, which means you have a minimum. Ooh, that's a lot of information. Sure. Yeah. The big thing is, don't just write a word and not show work, because that doesn't tell me you know what you're doing, you know? Because it could be a lucky guess. I want to know you know. Cool. Find the minimum or maximum value. Okay, so who knows how to do this one? How would we actually find what the min or max was? Yeah, it is the y value of the vertex, because that makes sense. The vertex is your point at which you're at the minimum. So if we find the x value of the vertex, we plug it in, we'll find the y value, which is the actual minimum. Okay, so we need to find, this is literally the y value of the vertex. So to find the y value, we have to find the x, which is negative b over 2a. So it's going to be negative 8 over 2 times a, which is 4. 8 over 8 is 1. So then I plug that back in and I'll find the y value. F of 1 is equal to 4 times 1 squared. Exactly. So the vertex is always where your min or max occurs. The vertex is where your axis symmetry goes through. What?
The x.
How do you know what a is?
B2A. B over 2.
Shh, hold on. All right, so b is negative 8, and we said a was 4. Okay, so this is going to be 4 minus 8, so it's negative 4? Does your math agree with me? Yeah? Okay. So, minimum is y equals -4. Minimum is at y equals -4.
Write the y.
Let's see. So it's find the minimum value. Minimum is -4. It just wants the value. It just wants value.
Just write -4.
That'd be fine, because you already found minimum in A. You can just write -4. Yeah. It's just asking for the value. It's not asking like where or the XY. It just wants like the minimum value. So we didn't do very many questions like this. But where this comes into play is like, you know, if you're like cost analysis, if you are literally a business person, you could model your sales as like a parabola, and you're trying to figure out, okay, well, how do I like get the most money for the least amount that I'm spending? So you can like, when you're optimizing, right? So using the min or the maxes, you're trying to like make the most money. So you're using your parabola to see the maximum. Or if you're trying to cut costs, where is the least expensive, right? So you're looking for the minimum where it's least expensive. So that's just an example of like, sometimes we don't go all the way, like where people actually really use this. I just want to give you an idea. Okay, we ready for the next one? Okay, so number 5, graph the following equation, determine its solution. Whoa, oh my God, so much to do. So first, we got to graph this equation. But this is weird. It's not in standard form. Remember, standard form, ax squared plus bx plus c. Right, so this is standard form for a quadratic. So this is non-standard form. What form is this in?
The simplified one.
Vertex. Who said that? You? Vertex. What's your vertex form? Wait, what does this mean? What is my vertex here?
It means that it's
So vertex form is y equals a times x minus h squared plus k. So I'll give this to you on your test, but I'm not gonna give you this part. I'll just give you the right side. So what this means is we don't actually have to do negative b over 2a, because that's only if you're in standard form. This vertex gives us the vertex. What's the vertex? What? Give you a hint. Vertex is h comma k. No.
It's 1
1, comma 0.
-1 comma -1. Please notice this is negative h, which means here I would have x minus -1 squared minus 1. So this is my h. This is my k. Because if I plug in a -1 for h, it would make it into a positive 1 right here. Because the formula has a negative right here. So my vertex is at -1.
But it also has the positive in front of K.
Yeah, well, positive k. So wait, if it's supposed to be positive, it's literally whatever. I would have to, okay, I see what you mean. So what I was going to do, okay, so add a -1. That's my k. Because remember here it's adding, so here I need to have adding. Okay.
The vertex was
So -1 comma -1. What is my, how do I want to do this? So the way I taught you guys to use vertex form is we use our parent function, just x squared, and we're going to shift all the values. So I'm going to use my parent function, and I'll shift all the values. So -2, -1, 0, 1, 2. 2 squared is 4, 1, 0, 1 squared, 1, 2 squared, 4. And what we're doing, so the vertex form, normally vertex is at 0, 0. But here we're shifting everything left 1 and down 1. So I can show you like 2 different ways to solve this problem.
what was the vertex again?
-1,
No,
-1.
what is the vertex?
Where the bottom of your parabola is, it's where you're turning from at your minimum or your max.
Got it.
So we're shifting everything left by 1. We're shifting everything left by 1. We're shifting everything down 1.
But I thought -1 equals -1.
What?
Is vertex is -1, -1?
Yes, x -1, y is -1 at my vertex. So it'll literally be right here. Normally my vertex is at 0, 0, but I'm shifting it over 1 and down 1. I'm shifting everything over 1, down 1. That's why I'm going through and subtracting 1 from all my x's, subtracting 1 from all my y's. So what I'm doing is every point I'm moving it left 1, down 1. Every point, left 1, down 1, left 1, down 1, left 1, down 1. So, like I'm going to rewrite my new points. Let's see, -2, 0, -1, -1, 0, 0, let's see, 1, 3. So I'm writing all of my points. Notice everything is shifting down 1 over 1 from my parent function. Remember the parent function looks like this, something like that. So if I would shift my whole parabola left 1, down 1, that's what this should look like. So I have a point at -3, 3, -2, 0, -1, 1, 0, 0, and 1, 3. So this is one way, right? When we were talking about vertex form, I showed you how you can literally shift things. How do you translate functions? How do you transform them? How do you just move a whole function? Okay, the second way of doing, yes?
You don't really have to find like H and K with that, right?
Oh yeah, you can look at it like you did the other stuff, remember?
Yeah.
Hold on. So we found H and K, right? I found the vertex. So this is one way of doing it, is showing, hold on, I want you to pay attention. Hold on. So this is one way. This is the way when we were talking about vertex form, how to graph, this is what I showed you. Another way you could do it, X, Y, was like how we did it up above, where I'm going to have 5 slots. Is that 5? Yeah. And I put the vertex in the middle. And then I pick the numbers that are around it. Oh, shoot, hold on. -2, -3, and I'm picking the numbers around it. And then you plug in -2, right? Plug in -2, blah, blah, blah. Plug it in up here. So I'm showing you 2 different ways to the
there's
same
another
problem.
way.
You only have to do it one way.
Wait, there's another way.
Hold on, let me finish this way first.
Okay.
So if I plug in -2, I get -2 plus 1 squared minus 1. Do you know where these numbers are coming from? Right here, the original equation. Okay. -2 plus 1 is -1. -1 squared is +1. 1 minus 1 is 0.
So wait, what is the equation that's going to go from 1 to
It's the one that's at the top of the page. It is x plus 1 squared minus 1. Hold on. So let me plug in -3. -3 plus 1 squared minus 1. Okay, -3 plus 1, -2. -2 times -2 is 4. 4 minus 1 is 3, which means that this is 3 as well, because this is symmetry. So vertex form shows us the vertex right away. So what I'm showing you, 2 different ways to do the same thing. So vertex form gives you your vertex, and you can make those 5 slots, right? The 5 rows, and do it the way we did before. Or you can understand that this is a translation. Everything is shifted left 1, down 1, and you can show it that way up here. Either one should give you the correct graph. So I have to see some work. Either you are doing this, or you're going to do this. If you do nothing and you have the right graph, you get 0 points. You must show your work. You must show your work. One more time, you must show your work. Okay. Okay, what is your question?
I want to show you there's another way that you shouldn't do it.
What's your question? What is it?
Okay, there's another way of doing this where you look at it and you see there's no negative, so it's going to be going down. It's going to be a smiley face. And then you can see that there's a positive, which means that it's going to be -x going 1 this way. And then the one outside is the y value, and the y value is negative, so the y value is going to be negative. So it's down 1 to the side 1, and then you can graph it like that. But you should never do that on the test, because then you don't show your work.
Yeah.
Well, I did that on the quiz, and I just like circled it, and I showed you. That's
But showed me, right? Like it was clear on your paper what you did. Because
Yeah, but you have to show your work, like the X and Y she has over there.
How did you get?
Just
So-
circle it, say go down.
You have to
So
show
what he did,
that you solved it.
so what he's talking about is this, right? So Dylan Benson, he's like, okay, check this. He circled it and he said down 1. He circled this and he said left 1. Like, that's giving me insight into your brain because you're telling me you understand how shifting works, right? Like that's cool. That's what I want, right? Ideally, we're having a conversation on your test, except you're not there, so I just have to go off what you wrote. Yeah.
Oh, and that's why it's a negative, because, you know.
Okay. So, graph the following equation. Done. We graphed it, but we have to determine its solution. What the heck is the solution?
-1, -1.
What do I mean when I say solution? Okay, because yeah.
Vertex.
The solution is the
Vertex.
roots. There are zeros. There are x-intercepts. When I'm looking for the solutions, I'm looking for my x-intercepts. Where are my x-intercepts?
So they align with the X.
Yes. So remember, those 4 words mean the same thing. Solutions, roots, zeros, x-intercepts. You graphed it and you can see the x-intercepts, yeah? Dang it. I thought you were answering the question. Go
0,
ahead.
-2.
Happy birthday. There you go.
0, -2.
So we have 2 solutions. One is at -2, 0. The other is at 0, 0. Notice, since the solution is an x-intercept, I need the x and y value.
Oh.
Ah.
We need both.
Alternatively, you could write -2 and 0, but notice I said x equals these. You can't just write -2, 0, because that's a point. That wouldn't actually be my 2. Right? Does that make sense? I want to really,
equal to
like,
X.
really clear. Just be clear that there's 2 solutions. Okay, cool. Okay, so that's 2 pages. Questions on the graphing so far? Okay. Oh, yep.
Victor.
You need your phone put away.
I
I'm not
am
asking you.
beaming.
I'm not asking you again.
I'm mean beam.
So that's not part of class. I've written on the board. I've asked you. You're losing participation for the day. I've asked you multiple times. I'm not going to fight you on you putting your phone away. Okay. So for question 6 or 8, factor given the expressions completely. Factoring. We must factor. It says factor completely. What?
Can you go back to like 1 there? I just need to see like what you wrote in the answer.
Okay.
-2, 0 and 0, 0.
Yep. Those are the 2 places the graph crosses the x-axis.
Cool. Okay.
Yep. Okay, so factor given completely. So we're not actually solving. All we're doing is factoring. So first step, how do we factor? Okay, greatest common factor.
No.
Is there a greatest common factor? No.
1.
Okay, is this a difference of squares? No. Perfect square trinomial? No. How do we know? How are we going so fast? How do we know?
Because 1 divided by 2
X divided by
times
X.
itself does not equal 30.
Okay, perfect. I hear the right answers. So,
-6 and 5.
yeah, okay. So we have to factor. But first, we got to make sure it's not a difference of squares because it's more than 2 terms. Not a perfect square trinomial because the middle, we divide by 2. I mean, that's not 30 when I square it. Okay, so I try to factor. So we're trying to add to 1, multiply it to -30. So let's see, x minus 6, x plus 5. What's wrong? -5? Oh, add to -1, yeah. Oh, yeah, add to -1, multiply to -30. So this one should be like a bread and butter. Like this should be like, this should be like the little softball lob to you. Hit it out of the park, home run. All you have to do is factor, so it should be x minus 6, x plus 5. This should be where your easy points come in. Okay. I just factor. We just have to factor. Not even solve, just factor.
Factory.
Okay, try out number 7. Try out number 7. Go through the order. Try out number 7. We're trying to factor.
How do you do that with the Y?
You just take it out.
First, is there a greatest common factor? Is there something in both these terms?
Yes.
So if I pull out y, I'm left with x squared minus 49.
With the square, so pull out a 7. Oh,
X
you also
squared
have to
minus
flip it
49 is a blank of blank. Difference of squares. Difference is a subtraction of squares. X squared and 49 are perfect squares, meaning something multiplied by itself is x squared. Something multiplied by itself is 49. If you take 7 and multiply by itself, 7 times 7 is 49. X times x,
and
x
times
squared.
X plus 7.
So we have y times x minus 7, x plus 7.
I got it right.
Hey. And like, this is enough work to show, right? Because it clearly shows me you understood to pull out the greatest common factor, right? I see the y is outside. Then I can see it's a difference of squares. If you got stuck on this, and if you didn't pull out the y, I mean, showing some work is always better than nothing. Because if you leave it blank, it's automatically all points gone. If you at least attempt the problem and something is right, then I can give you partial credit. Okay, so we're good. You're always going to try every problem.
Next one's the same thing.
So I'm going to write this out. Y times x minus 7, x plus 7. Cool. Because I'm not asking for like a giant thesis. I just want to like see your thought process. Okay, let's go through. Sorry, was that too fast? Let me come up a little bit. So don't say anything out loud. Hold on. Don't say anything out loud. I want you to try this in your brain first. So, is there a greatest common factor? 3, 2, 1. Greatest common factor for number 8? No, there's not. Because x squared has 1 in front of it. Okay. Is this a difference of squares? No. We're going through our special cases now. Is this a perfect square trinomial?
Yes.
How do you know?
Because 4 divided by 2 is 7 and 7.
Hold on. Ruby, what'd you say? Okay. We always check greatest common factor first. Is there anything I can pull out?
Yeah.
So, for example, number 7, there was a y I could pull out.
I know I can figure out what to do. I just don't know explain it.
Difference of squares, for example, is when you have like x squared minus 4. So you have two things, and you're subtracting them, and they're both squares.
I have a question.
Just a moment. Let me finish explaining this, then I'll get to you. Okay. And then, so this is like difference of squares. Our two special cases, perfect square trinomial. Perfect square trinomial. So example for this one would be like x squared minus 2x plus 1. Because what this is equal to is x minus 1, x minus 1. So then you could write it as like x minus 1 squared. Perfect square trinomials, the big thing is what?
The difference of squares.
No.
Number 8? No. Because difference of squares always has 2 terms. This one has 3.
I have a cool question.
Okay, hold on. Let me finish going through this.
Yeah, okay.
So perfect square trinomials have the same factor, 2 of the same factor. And then this is always your order you go through in factoring. This is on page 27? I think 27. Like it's in your notes.
Can't you also just do?
And then hold on. And then you try factoring, and then when everything else, you've tried everything, that's when you use the quadratic equation. Okay, Ashton's question, then
Okay,
Isabella.
Question, if 14 was 16, could you do the greatest common factor?
No, because there's still a 1 in front of x squared.
I know, but it's x squared.
No, the coefficient's 1. We're looking for the greatest common factor between the x squared term,
But they're all
the
square, so if you can pull out a square,
No,
16,
no,
39,
no.
X
When you're
squared.
pulling out greatest common factor, you have to pull out the same thing out of every term.
you can't pull out one giant
No,
square.
no, nope.
Okay.
Okay, Isabella.
I was just gonna say, like, can't you just do it like how the first one, like adds to -14 equals to
If you can recognize it's a perfect square trinomial, then that would be ideal.
Like you didn't
That's
ask
what I
us to
did.
do it in like a certain way, so it would be
Right.
so-
So that would be fine, but like, if you show me this, that's what? I'm doing exactly what I planned on doing when I woke up this morning. This is how I planned on solving this problem. Okay, so what I'm trying to show you is like what work will give you full credit. This one right here. If this is all you write, and then you come over here and you write x minus 7 times x minus 7, That's not tons of stuff to work. That shows me it understands a perfect square trinomial, meaning,
So we get credit.
No, x minus 7 squared?
well, I mean, x minus 7 times x minus 7 is fine. When you're completing the square, you should write it as square. Completing the square method, you should write it as square. But here, it doesn't matter. These are my two factors. Because if
Taken down and written like that?
when I say it doesn't matter, that means it's fine.
Okay, good.
Okay.
For like,
So,
6.
if instead for number 8 you did like, oh, adds negative 14, multiplies to 49, you could say, oh, okay, so I know this is going to be x minus 7 and x minus 7. That's fine as well. I just got to see some work.
So we would have to do the same one for like number 6.
More or less, yeah.
Okay.
I've asked you, put away your phone. You shouldn't have your phone either.
I don't have
You
my
literally heard me, so like you both are losing points for today. Literally don't have your phone. Okay. It's written on the board, it's in the syllabus, I say it verbally multiple times, and every time I say it and you don't put your phone over there, it's another point off. There's 4 points per day. It's possible to lose your full points. Okay. Use the parent function f of x equals x squared to describe the transformation. So we're looking for like, how do we go from x squared to this guy? What is being, how are we moving? What's being changed? So turn to the person next to you, discuss for a second. What's being changed?
There's no parentheses, I think
It's to the
no,
right.
you squish it, remember?
Shifts up by 3. So that's this guy. Right, so that's that. The negative is being reflected across the x-axis.
Sad face.
Reflected across, do you know what I mean when I say reflected? You can say flipped,
Yeah, but why
mirrored
is there a parenthesis?
across the x-axis. What do you mean?
Isn't there supposed to be parentheses?
What do you mean, parentheses? Like 1/3 x minus something squared?
Yes.
So it tells you there's no horizontal shift because there's no parentheses. And then we have a vertical compression. Vertical compression by 1/3. Because we're multiplying all our y's by 1/3. And what's that doing? So if you multiply everything by 1/3, it's getting compressed, right? You see the y? You see my parabola? It's being compressed. It's going down. It goes from a regular parabola and it's being compressed. It's widening out because you're shifting all of your y values down, right? You're multiplying by 1/3. Awesome. Okay. We could definitely knock out 10. Do we have questions about this one? No. Okay, number 10. So for 10 through 11, solve each, sorry, someone said wait. I'll go up a little bit. All right, solve each equation using the method indicated. So this is what I'm talking about. I say how you have to solve it. You don't solve it that way, you don't get the points. That's why we're going through it right now in class. Solve by factoring. So I must factor. I don't have to go through the order because it told me exactly which method to solve.
You can square.
So this is a difference of squares. Yeah. So I have x squared minus 9, x squared plus 9. But then what about this one right here? This is a different square of squares as well. X minus 3, x plus 3, and don't forget to bring this one down, x squared plus 9.
Why do you have to bring that one down?
Because I'm trying to fully factor it out.
But we did because you.
So I've fully factored it now.
Oh, so the x minus 3 and x plus 3
Comes from the x squared minus 9, yeah. So then, to actually solve, when you're solving, you set each factor equal to 0. Talia, sit up.
Isn't the right one x?
Okay, I can't answer two people's questions at once. Isabel, then Dylan. What's your question? Hold on. What?
Can't you just do the same that you did to, like, can't you just do x minus 3, x plus 3, and then x plus 3, x plus 3?
No, because x plus 3 times x plus 3 is a perfect square trinomial. X plus 3 times x plus 3, if you FOIL it out, you get x squared plus 6x plus 9. We don't have that 6x. So to solve, you set each factor equal to 0. So I set x minus 3 equal to 0. I see x is equal to 3. I set x plus 3 equal to 0. I see x is equal to negative 3. Then I set x squared plus 9 equal to 0. I see x squared is equal to negative 9. If I square root both sides, I get plus or minus the square root negative 9. This is the same thing as plus or minus I root 9, which is plus or minus 3i. So the solutions would be 3, negative 3, 3i, negative 3i.
Oh my god, you have to write that out?
Ooh, look at us going. Yeah. Woo. Okay, cool. That's where we'll end, and we'll go over the rest of the practice test, I guess, next time, along with some questions.